Have you ever gazed up at the night sky and wondered what secrets lie hidden in the vast cosmic dark? What if you could bend space and time, taking a shortcut across the universe in the blink of an eye? This isn't just science fiction, it's the tantalizing promise of a wormhole, a concept first theorized by Albert Einstein and Nathan Rosen. They called it an Einstein-Rosen bridge, a hypothetical tunnel connecting to distant points in spacetime. Imagine the universe as a giant sheet of paper. To get from one side to the other, you'd have to travel all the way across. But what if you could just fold the paper and poke a hole through it? That hole is our wormhole. It's a cosmic shortcut, a gateway to the unknown. Today, we're not just going to talk about wormholes. We're going to embark on an epic journey and fall into one. Strap in, because we're about to defy the laws of physics as we know them, and explore what might happen if you took the ultimate leap of faith into the heart of a space-time tunnel. This is your theoretical guide to surviving, or perhaps not surviving, a trip through a wormhole. Our journey begins at the edge of the abyss, the mouth of the wormhole. From a distance, it might look like a perfect sphere, a dark orb hanging silently in space. But unlike a black hole, it doesn't devour light. Instead, it warps it in bizarre and beautiful ways. As we get closer, the stars behind it would appear distorted, their light bending around the intense gravitational field. This effect, it's called gravitational lensing. It's like looking through the base of a wine glass. The universe becomes a swirling, psychedelic canvas. The entrance, or the event horizon, is the point of no return. The gravitational pull here is unimaginable. Our ship's sensors would be going haywire, warning us of tidal forces that threaten to tear us apart. These are the same forces that cause tides on Earth, but amplified to an astronomical scale. The front of our ship would be pulled more strongly than the back, stretching everything like cosmic taffy. We brace ourselves, push the engines to their limit, and plunge headfirst into the unknown. The view outside our window transforms into a kaleidoscope of light and color as we cross the threshold from our familiar universe into the throat of the wormhole. We're in. We've passed the event horizon and are now hurling through the tunnel, the throat of the Einstein-Rosen bridge. What would we see? It's unlike anything we could ever witness in normal space. The walls of the tunnel aren't solid. They're a shimmering, fluctuating boundary of space-time itself. Through Tim, we might see distorted glimpses of our destination. The light from a distant galaxy or a nebula we've never seen before, all warped and stretched. It'd be like flying through a tunnel of cosmic mirrors, reflecting a universe that is both familiar and alien. Physicists believe that to keep a wormhole open, you'd need something truly extraordinary, exotic matter. This isn't the stuff that makes up stars, planets, or us. Exotic matter has a bizarre property: negative mass. While normal matter pulls things together through gravity, exotic matter pushes them apart. It's this anti-gravitational property that would theoretically prop open the throat of the wormhole, preventing it from collapsing in on itself the moment it forms. Without this exotic scaffolding, our tunnel would be incredibly unstable, snapping shut faster than the speed of light. So, as we travel, we are surrounded by the most mysterious substance in the universe, the very thing that makes our journey possible. The light from our starting point would be intensely blue-shifted ahead of us, and the light from our destination would be red-shifted behind us, creating a spectacular display of cosmic fireworks. Now let's talk about the physics of this insane ride. The biggest danger inside a wormhole isn't getting lost. It's being ripped to shreds. The term for this is spaghetti. As we mentioned, the tidal forces are extreme. The difference in gravity between your head and your feet would be so immense that it would stretch your body into a long, thin strand, like a piece of spaghetti. It's a gruesome thought, but it's a very real consequence of extreme gravity. However, some theories suggest that a sufficiently large, or supermassive, wormhole might have gentler tidal forces at its entrance. If the wormhole were billions of times the mass of our sun, the stretching effect across a human-sized object might be survivable. But even if we survive the tidal forces, the instability of the wormhole itself is a huge problem. The slightest disturbance, even the presence of our own ship, could cause it to collapse catastrophically. Imagine the tunnel walls rushing in on you at nearly the speed of light. There would be no escape. Furthermore, the radiation inside could be lethal. As we travel, we might be bombarded with high-energy particles and photons that have been trapped and amplified within the wormhole. It would be like flying through the core of a nuclear reactor. To survive, we'd need a ship made of materials we can't even dream of yet, capable of withstanding unimaginable forces and radiation. This journey is a delicate dance on the razor's edge of theoretical physics. Against all odds, let's say we've made it. Our ship is intact. We haven't been spaghettified, and the wormhole didn't collapse. We see a light at the end of the tunnel. A brilliant, blinding exit. We burst through the other side, emerging from the wormhole's exit mouth. Where are we? The answer is anywhere. And anywhen. A wormhole doesn't just connect to points in space. It connects to points in spacetime. We could have emerged in the Andromeda Galaxy, 2.5 million light-years from home, allowing humanity to become an interstellar species overnight. Or we could have emerged in our own galaxy, but billions of years in the past, with the chance to witness the birth of our own solar system. This is where wormholes get even stranger. They are theoretical time machines. By moving one mouth of the wormhole at near light speed and then returning it, you could create a time difference between the entrance and the exit. Stepping through one way would take you to the future, and stepping through the other would take you to the past. This, of course, opens up a whole can of worms, from the grandfather paradox to the question of whether we can change history. It's possible that the laws of physics have some built-in protection. A chronology protection conjecture, as Stephen Hawking called it, that prevents such perhaps the wormhole would collapse the moment a time paradox was about to be created. Our destination is the greatest mystery of all. A new galaxy, a new time, or maybe even a completely different universe with different physical laws. The possibilities are as limitless as the cosmos itself. So, after this wild journey, what have we learned? We've learned that traveling through a wormhole would be the most dangerous and awe-inspiring experience imaginable. It pushes the boundaries of everything we know about the universe. Right now, wormholes remain purely theoretical. We have never observed one, and we have no idea how one might form naturally. Even if they do exist, they are likely microscopic and fleeting, appearing and disappearing in the quantum foam that underlies reality. The challenges are immense. We need to find one, figure out how to stabilize it with exotic matter that we don't even know exists, and then build a ship that can survive the trip. It's a task for a civilization far more advanced than our own. But that doesn't mean we should stop dreaming. Every great leap in human history, from crossing oceans to landing on the moon, began as an impossible idea. The study of wormholes, even if they're just mathematical curiosities, forces us to ask deep questions about the nature of reality, space, and time. They represent our unyielding curiosity and our desire to reach for the stars. Maybe one day, our distant descendants will look back at this era as the time when the journey across galaxies was just a dream, a wild story told in a video, and they'll smile just before they step into the light. Thank you so much for joining me on this incredible journey through space. If you enjoyed this cosmic adventure, don't forget to like, subscribe, and hit that notification bell for more explorations into the mysteries of our universe. Until next time, keep looking up.